So hi everyone. So we are going to start with the second unit of this chapter, motion in one dimension, and the second unit is graphical representation of linear motion. So means that now we are going to represent this linear motion in graphical form. So here we are going to draw the first graph, which is displacement time graph. So here for this displacement time graph, as this is the two quantity, one is displacement and the one is time. So this displacement we are going to plot in y-axis, and this time we are going to plot in x-axis. And here this graph shows this object is stationary, means that this object is at rest. Then this is the second graph of displacement time graph. Again, this displacement is in y-axis and time is in x-axis, and here this is the straight line which shows this object is uniform motion. This means that for every second of motion this object travels with uniform velocity. Thus this graph comes as straight line like this. And again, another kind of this displacement time is graph, what you are observing that this line comes here as curved line. So this curved line shows that this is an object which is doing a motion of variable velocity. Now, so these are the three different kinds of graph you have seen for displacement time graph. One is for stationary object, means that when object is at rest. One is for uniform motion, and third one is for variable velocity. Now what is the use of doing this graph, displacement time graph? Why do we plot this graph? So we plot this displacement time graph to find out the velocity. Now the question comes here that why and how we are going to find out the velocity with the help of this graph. So to find out the velocity with the help of this graph, what we are going to do, we are going to find out the slope. And how do we find out the slope? By making it by completing a triangle. So suppose this is a graph and here we have completed this triangle. So when we have completed this triangle, what we are going to see here that this is the y2 portion, this becomes a y1 portion, again this becomes x2 portion, and this becomes x1 portion. And now when we are going to divide, and this is considered here, this point from here to here parallel to y-axis is considered as delta y. This x portion, this portion is considered as delta x. Now when we will divide this delta y by delta x, we can able to find out the slope, and whatever the magnitude we are going to get with this, that will be velocity of an object. Now if this is, now the next graph is when the object is in variable velocity. The graph comes as curve. Now to find out the velocity for this curved graph, what we do, we take any point here, here, or anywhere. We will take one point. Suppose I have taken one point here, and on this point we are going to draw a tangent. Now, and after drawing this tangent, we are going to complete this triangle. And after completing this triangle, similarly like this graph, we will find out the slope and object. This portion will be considered as delta y, this portion will be considered as delta x, and again we will find out the slope, and we can able to find out the velocity of an object. So this means that this is the different types of velocity time graph: stationary for stationary object, uniform velocity, or variable velocity. For all these three different kinds of motion, with the help of displacement time graph, what quantity we got as a result? We got velocity of an object. So next portion is velocity time graph. So now what we are going to do in this velocity time graph, suppose this graph is plotted for different velocities of an object for different time duration. So what do we observe? That we got three different areas. This is one triangle, this is one trapezium, this is another trapezium. Now what we are going to do with this quantity, what is the use or the purpose of drawing this velocity time graph? So to understand this, we should understand this small formula. So as we know that distance is equal to speed into time. So this means that when we are going to multiply speed into time, what quantity we got? We got distance. So this means that similarly, whether you call it as speed or whether you call it as velocity into time. So what we have done in this velocity time graph, we have drawn velocity in y-axis, we have drawn time in x-axis, and when we have multiplied this x and y coordinates, what result we have got? We got displacement on object. So this means that with the help of plotting velocity time graph, we can able to find out the displacement of an object and total distance covered by an object. So how do we find out total distance covered by an object? What we are going to do, we are going to find out the area of this triangle, then area of this trapezium, then area of this trapezium, and when we will add these all, so here all these areas are added, and what we are going to get, we are going to get the total distance covered by an object. Similarly, to find out the displacement on object, what we are going to do, we are going to subtract this negative part. Now here one more thing, so this upper portion is considered as positive portion of the graph, and this lower portion is called as negative portion of the graph. So whenever we are going to subtract this negative portion of the graph from the positive portion of the graph, we can able to find out the displacement. That is what we have done. So here this is one trapezium which is subtracted, another two portions are added. This is area of triangle, this is area of trapezium is added, and this area of trapezium is subtracted here, and thus we can able to find out the displacement on object. So this means that under velocity time graph, first we find out the area, and once we find out the area, what we are going to get, we are going to displacement of an object by finding out the area, and when we will add all the areas, we can able to find out the total distance, and when in that all areas, when we are going to subtract the negative portion, we can able to find out the displacement on object. So this is about velocity time graph. So next we are going to study about acceleration time graph, and here we have taken an example of motion under gravity. So when an object is under freely falling condition or motion under gravity, what is going to happen? As we know that it is going to fall down with uniform acceleration. So this graph shows a graphical representation of freely falling body under gravity. So this is a straight line. Now what we are going to do with the help of acceleration time graph, we are going to convert it into velocity time graph. Now once again, so here again you got this acceleration time graph. So again we should understand what is the use of plotting this acceleration is in x-axis and time in acceleration in y-axis and time in x-axis. So as we know the formula, acceleration is equal to v minus u by t. So this means that again when we will multiply a into t, means acceleration into time, what quantity we are going to get? We are going to get change in velocity. So this means that again acceleration is here in y-axis, time is in x-axis. So this means that when these two coordinates a and t is going to get multiply, what result we are going to get? We are going to get a result of velocity. So this means that when we will multiply, so now what multiplication, how we are going to do the multiplication here? So the multiplication is going to be done by finding out the area. Suppose this is the graph you are observing. So now we will find out the area of first rectangle, second rectangle, third rectangle, and the fourth rectangle. So these four different rectangles will give us the distance covered by, velocity attended by an object at different seconds. This means that when we will multiply acceleration into time, we will get the velocity, and then we will tabulate it and plot a graph. We will get a graph like this. So this means that acceleration time graph is further converted into velocity time graph. And just now we have discussed here that further what we can do with the help of velocity time graph, again when we will multiply velocity into time, we can get the displacement. So this is all portion about the acceleration time graph. So this means that again one small recap. So we are seeing here chapter 2, motion in one dimension, and its unit 2, graphical representation of linear motion. The first topic we have seen displacement time graph. This graph shows a stationary object. This graph shows uniform velocity. This graph shows variable velocity, and here we find out the slope of an object by doing delta y by delta x. Then we have seen velocity time graph. Then in this velocity time graph, by finding out the area of this triangle, this trapezium and this trapezium, what we found out? We find out the total distance. And when we have subtracted this negative portion, what portion we have found out? We find out the displacement of an object. Then next we have seen acceleration time graph. So this is acceleration time graph, and we have used this formula. So here a into t is multiplied, and what quantity we got? We have got change in velocity. And when we have got change in velocity, we have plotted the graph of velocity time graph. And again, when we have multiplied v into t by finding out its area, what quantity we are going to get? We are going to get the displacement of an object. So this is all about the topic of unit 2. Thank you.